How has it been, with your go-to-market strategy? Like, okay, how do we sell this thing, and who do we sell it to?
I mean, on one side, we've been very fortunate because we've gotten a lot of interest from very early on. We've been working with some amazing partners that enabled us to, get to the point that we're at today. But I think the key thing is obviously, just working with the end users as much as you can, and getting their feedback and making sure that you're not building what you think should be built, but more what they want.
So would this, in theory, work for rice?
It can work for rice. We've done some work with rice in the north of Italy. Unfortunately, there's no rice grown in the UK.
I was going to say you need to go to Southeast Asia with this thing as fast as possible for rice. And we're back for another episode of the Startup Hustle. This is your host today, Matt Watson. Excited to be joined by Lorenzo Conti today. We're going to talk about something interesting, building robots that can swim through grain. So this should be a really fascinating conversation. Lorenzo is the founder and CEO of a company called Crover. You can check him out at crover.tech. Before we get started, I do remind everybody that today's episode is brought to you by Fullscale, which is my company. We've helped over 100 other startups and scale-ups grow their development team from our team in the Philippines. If you need to grow your development team, QA, product management, UX, all these different things, front end, back end, mobile, check us out at fullscale.io. Lorenzo, welcome to the show, man.
Thank you, Matt. Delighted to be here.
Now, I don't know if I've ever had somebody on the podcast from Scotland. What's it like having a startup or a tech business in Scotland?
It is a very exciting ecosystem. I would say it's got most of the things that an entrepreneur can wish for. Possibly the exception of large investment capital. I think if we had that in Scotland, like there is in the US, then the ecosystem would thrive a lot. There's just a lot of challenges here for businesses to scale, which is why we're also kind of in the process of setting up our operations in the US. But other than that, it's a fantastic ecosystem, and we can enjoy all the benefits of being in Scotland with a beautiful landscape.
So what makes it fantastic? Is there a lot of talent? Is there a lot of access to like early stage capital or grants or tax benefits? Like what makes it great in Scotland?
So there's a lot of support, especially in the early stages, universities and other organizations here. Especially in our case, coming from the University of Edinburgh, we've received a lot of support from the start to get through the first steps. You mentioned grants as well. There's definitely a lot of good, grants. On being in Scotland also means that you have access to support both from the Scottish government and the UK government. So it's kind of that nice duality where you've got multiple options available. As you can probably tell from my accent, I'm originally from Italy, but I've been in Scotland for the last 14 years. So I very much like it here.
I'm not an expert on European accents. I would have never figured that out. But so where did you originally come up with this idea? Like you originally started this right out of college, right? Where did you come up with the idea for this company?
A little bit after college. I mean, I was doing my PhD at the University of Edinburgh.
Okay.
I was I'd already done a kind of bachelor and master and a little bit of work experience before that. I was working in the field of granular materials, which is a bit of a funny word because a lot of people, when they hear it, they're just like, what is that? I've never heard of that. But they're actually the largest family of traded commodities worldwide. It's weird to think about it, but even more granular materials are traded annually than fluids, and everyone knows what a fluid is, right? And granular materials is really any system made of solid discrete particles, like sand, grains, or powders.
Sugar.
And sugar. Yeah, that's a really good example as well. I usually like to think about it as the grown-up version of ball pits. When you're a kid and you go to McDonald's, and
Yeah,
they're kind of
we have
they're a bit like
those.
that.
We have those corn pits here in Kansas City where you can go and there's like little family places and jungle gyms. There's like big things of corn you can go and play in the corn and stuff. So
Yeah, so as a grown up, I just had fun studying the physics of those systems as well, which are actually a bit more complicated than one realizes. But and I was working specifically on studying non-local effects in these types of systems. So when you have something happening at a certain point in space in there that affects a different point into that system. So saying you're sitting in your corn pit, and it's able to support you on the top, but then something happens at the bottom of the bulk, and you start sinking into it. That's a really good example of a no-local effect. And I was lucky enough to discover that there is a coupling, so a connection between rotational motion and translational motion in these types of system, which really led to the development of the first feasible method for moving through these types of system. So we kind of, starting from the physical discovery, we were able to develop the first device in the world able to move through sand, the grains, or powders a lot more efficiently than the worm in the movie Dune.
well, I'm excited to see Dune 2 when it comes out here in a couple weeks, by the way. But so was your idea originally to build like a robot or something that would do this? Or how did, like, what was the original goal? Was that the goal from the very beginning?
I mean, at the very beginning, there wasn't a specific goal. I was just, doing research, looking for, exciting new physics. Also, to complete my PhD, that's never a fun process when you're getting towards the end of it. And then I realized that since there wasn't anything like it before, and there had been a lot of attempts to get objects to move through these types of systems that had been unsuccessful,
Okay.
I realized that there was a lot of potential. And initially, I started thinking about applying it in space. Like NASA and other organizations, they send rovers into Mars
Right.
and other places, and they usually have to avoid sand dunes or regolith dunes because they're really tricky environments to move into. Also, they build really bulky and heavy structures to go into the surface of those things, which is very expensive because the heavier the payload, the higher the cost. And also from a physics point of view, I thought, okay, like there's no organic matter as far as we know in these places. There's little to no water moisture, so it's even closer to the pure physical system, and so it should be easier to move through them. But obviously, from a commercial point of view, that's kind of a longer term target,
Yeah.
and it doesn't have as much impact. So then I started thinking about things more on Earth that would have a bigger short to medium term impact.
So if you have now built this technology and you can use it with grain or sugar or sand, corn, all these different things, what is the value to them? Why would they want to use this?
There's a lot of angles to it. I mean, obviously, one is helping maintain the quality of grain stocks. Grain gets harvested, it goes into storage or in transportation. In a lot of situations, it stays static in sheds or silos for long periods of time. It could be days, weeks, sometimes even years, right? We sometimes see places where they keep stocks for 2 years or longer. Obviously, those are the less frequent cases. Most situations is kept for a few months. And during that period, there's currently no way to properly assess what the quality of the stock is and help maintain it, other than static sensors and taking like very dangerous walks on those bulks. So the most common way of kind of managing these bulks is still having a person to physically walk on top of them with a and spear, and run the risk of sinking in through what people call grain entrapment, which is a really bad way to go. And that brings in like the health and safety aspect as well. We're hearing from more and more companies that want to improve the health and safety of their operations, or that currently have no option at all to manage their bulks because they have no feet on the bulk policies. And so, those are kind of the two main angles that we started with, monitoring the grain and helping maintain its quality and improving the health and safety of operations. But as we went through the process of gathering more user feedback and working with more organizations, we are just we've been discovering a lot of other reasons why people want our system, and other key reasons is also reducing the cost of cooling and aeration, which is the main way in which people can control the conditions of grain bulks. And currently is done in a very inefficient manner, whereby people just activate aeration fans during the warm months, at night, constantly, and especially with the current like energy costs, that is often the largest cost of running these grain stores.
Well,
And so we can reduce that and make it more efficient.
well, it sounds like you could almost create a new industry here where when somebody goes to buy grain or one of these kinds of products, they almost expect it to be inspected before they would buy it, and they would use like your product to inspect the grain before they would buy it.
Yeah, 100%. And I mean, initially we had all these ideas to entirely revolutionize the grain industry, but one challenge with kind of changing significantly the way people do things is that it takes time and a lot of money. And so we changed our plans towards kind of more iterative improvements. So right now we've aligned ourselves to the way people do things, and we make it better. But hopefully in the long term, we can also help redesign the entire system from the core.
How big is this device?
So we've got the kind of main part of the robot that goes into the bulk, which is quite small. We've got different incorporations of it, but the largest one is 8 centimeters in diameter. And then we've got what we call the mothership of the system, which carries the heavy payloads, moves on the surface, can climb like steep bulks, and we can fit like different modules into it, and that's a bit larger. But about 60 centimeters is the largest.
We don't have centimeters in the United States. How big is that?
I know. I was thinking that as I was saying it.
Like 3 inches.
That's that's about 20 inches.
The big one's about 20 inches. Okay.
Yeah.
But you said the smaller one was only about 8 centimeters. Is that what you said?
Yeah, so that's about 3 inches.
Yeah. Okay. I'm just joking with you.
No, I know I need to learn my inches. Yeah.
At Full Scale, we have a lot of employees in the Philippines, and I've been over there 14 times, and what's interesting there is they like half use the metric system and then half use I guess they call that the imperial system or whatever. So like, some things, like if you have a baby, they weigh it in pounds for whatever reason, but for an adult, they weigh them in kilograms. I don't understand why. But the temperature is in Celsius, but other things are in kilometers. Like it's totally all over the place. But anyways, I always have fun with that. But so what are the key like types of sensors you had to put on this thing? Like I'm just fascinated about like what does this thing do? Are you looking for like insects? Are you looking for humidity? Are you looking for like other toxins? Like what can you find with this thing? I'm just really fascinated by this.
So we started with temperature and moisture because those are the main 2 parameters of grain quality, and also like the classic methods of what people call integrated pest management.
Okay.
They are based on keeping an eye on the temperature and the moisture of the stock and making sure that those 2 parameters stay within a safe range that prevents the growth of pests like insects and molds, right?
Okay.
Those are biological entities. Like every grain comes from the field with some amount of spores or eggs. So it's mostly about making sure that those things they cannot grow, right? It's about creating an environment that is not good for them to live in. And then obviously, in reality, things are a bit more complex than that. So we're in the process of implementing carbon dioxide readings as well, which is kind of more in line with more modern models that interpolate, carbon dioxide with temperature and moisture. And we've been since some time like doing a bit of work on trying to develop more advanced sensing as well for other parameters like mycotoxins and protein. The challenge there, too, is that when we go beyond temperature, moisture, and carbon dioxide, there isn't really like a suitable small sensor that fits all the requirements for use in the stock that really can measure these things. So we're having to design other things from scratch. But already with the three main parameters that I mentioned, there's a lot of things that can be predicted in terms of mold growth and maintaining the grain quality.
So all I can think of is you guys are working on this. You got your prototype. You're so excited to test it. And worst case scenario has to be you put this in the grain and the damn thing gets lost in there and it gets stuck in the grain. Did you guys ever have that problem?
Yeah, I don't know if you ever had a grain store yourself, but that's literally like the first question we get kind of 90% of the time from grain storage operators, or at least used to. And that was because we started with a remote version of the device. So battery powered. We know cables, and so obviously if it failed, it was lost in there. And that is a contamination problem, effectively. If you go and sell your grain and someone finds like a blue device in there, that's they're not going to be very happy. And so we moved primarily to a tethered version. Like
so it's tethered.
We're still so that even if it malfunctions, it can be retrieved. And also for a few other kind of safety considerations as well.
So you mentioned earlier about maybe setting up an office in the U.S. Please tell me you're coming to Kansas City. Where is like Grain Central? Where do you plan to come?
So we are slowly making our way towards Kansas City on the Midwest. For now, we're setting up an office in upstate New York, in Rochester.
Okay.
Because we got a bit of support there through an organization called Grow New York, as well as Cornell University, and also is somewhat one of the closest places to the UK in terms of time zones and other things. But the plan is to kind of keep expanding towards the West.
Yeah. Well, definitely you want to get to the Midwest here. There's a whole lot of farming and stuff around here. So what did it take technology-wise to build this? Like, when people think of tech, they think of like, oh, I'm going to build this web application and what kind of front-end development, framework do I need? And what does my tech stack look like? And like this is totally different. How do you build the technology for this?
Yeah, there's a lot of parts involved there. I think possibly the biggest challenge has been the fact that there wasn't any device out there that looked or worked or moved like our device does, and so we had to basically write the guidebook ourselves, fail a lot of times, iterate more than usually required through the various designs, because it's really hard to predict how things are going to behave in grain or in any type of granular system. So a lot of things, until you actually build them and test them, you don't really know what's going to happen in there. And you can simulate them as much as you want. I mean, there's what people call discrete element modeling for simulating granular systems, which was a core part of my PhD as well. But it doesn't matter how much computational power or other things you've got, like those models are not perfect. And so we had to put together a team of engineers covering various areas. from mechanical engineering to electronics to obviously robotics and automation, and really figure out a lot of things ourselves, from the way the device moves in practice, in grain, just starting from the physical concept and turning it into like a practical design, to the automation side of things, even from the electronics side, because the requirements of the system like ended up being very different from other things like drones and so on, for which a lot of subsystems and components are usually designed for. We had to spend a lot of time either designing things ourselves from scratch, or doing a lot of communications with supplier to get them to build kind of customized versions of,
Well, it had to be
of
like
their thing.
airtight almost too if you're going to keep sand and sugar out of it and stuff.
Yeah, 100%. I mean, IP rating was essential for all the parts, which obviously like restricts the options that you've got, right? You might find a part that has amazing specs, great price and everything, but then maybe like an IP rated version doesn't exist, and you've got to encapsulate the whole thing, and then it becomes like really bulky and heavy as well. So especially lately, we've been having to spend a lot of time like reducing the weight of the whole system, because when you start making everything, like you said, IP rated and intrinsically safe, it gets heavy, it gets bulky.
Yeah.
Making things also safe to like be in contact with grain, right? Like a lot of plastics are not, and so you end up using a lot of metals into the system, and
So when you guys, I'm just fascinated by this. So when you guys put this in the grain, do you like drive it around kind of like it's a drone, or is it more like a Roomba or something for a vacuum cleaner where you just put it in there and then it just starts running around and it kind of maps out everything up and down? Like how does that work?
So driving it around with a joystick, where you've got like a camera feed as well,
Oh,
is
okay.
the present. But then it operating autonomously like a Roomba, like you said, that's really the target.
Okay.
So full automation of the system is one of the key focuses for us right now. We've managed to automate part of the operation, but there's still quite a bit of work required, and that's another thing where like there's a lot of like automation packages available out there, and routines that by now have been very established for things like stabilizing and automating like the movement of drones, but things in grain, they move very differently.
Oh
There's a
yeah.
lot of like fluctuations, like, and there isn't really like, I mean, there's hardly any study out there of how to move something like our system in this type of environments, and so that's really one of those big things that we've had to figure out ourselves, and we're still improving. I think it's one of those things that we're just in the early stages of that technology still in some way, and there is probably going to be amazing and super stable in a few years, but um, yeah.
So are you still kind of manufacturing these kind of by hand one by one? And like you're almost using like an Arduino or whatever and kind of putting the pieces together in this thing? Or have you got to the point now where you have like figured out all the specs and you had to go to like China or somewhere and have them manufacture them for you? Like tell us about how you manufacture this thing.
Yeah, we've got some tight requirements, for the certification of the system, that mean that we couldn't use some kind of obvious type of parts, like Arduinos, like you mentioned, and so we had to we had to source either suppliers that were specialized in parts that met all our requirements and had the right compliance, or design them ourselves and get them tested and so on. So in terms of the manufacturing, because there's so many parts to the system that have to come together, we've got suppliers for kind of some specific components that are off the shelves, and then we've got others that we effectively subcontract the manufacturing of.
Okay.
I guess one of the big pieces that we're working on um, for our activities in the US is also trying to set up some manufacturing
Okay.
for North America in there, and that's one of the main things that we're planning to do in upstate New York.
So how many parts are in this thing?
It's quite a bit. I can't remember the number, but we've got a variety of bills of materials for the various subsystems. One positive change that we've been making over the last months is moving the system more towards like a modular approach.
Okay.
Where we've got like the main
Different
platform.
sensors and.
Yeah, exactly. We can fit different things onto it, especially since we've had a lot of requests for like a sampling module where we can collect physical samples from within the bulk.
Yeah.
And that's possibly been even more requested than the kind of sensing piece. And that's kind of close to being ready now, and so we're hoping to start commercializing that one soon as well.
Yeah, that sure beats was the old way. They'd stand on top with a stick with like a giant spoon on the bottom or something and try and fish out some of the material from the bottom. Like, how did they do that before?
Yeah, 100%. Yeah.
So yeah, just being able to go down and have it like, okay, go down so many meters and collect a sample, like that would be probably super valuable to them.
Yeah, and I mean, in the end, like we really see the Crover robot as a platform to enable different technologies to reach parts of the boat that they couldn't otherwise. Like, we don't want to develop every single sensor that could potentially be fit into it for every possible application, because obviously there's also things beyond grain. There's like the mineral industry, like chemical powders, pharmaceuticals, you name it. We don't possibly have the time to work on every niche application, and so eventually we also see the possibility of like providing the robo as a like the basic kind of platform so that other people can fit their own sensors onto it and tailor it to their own application.
I mean, you never know what people could use it for, right? Like, I guess there's somebody somewhere that has a giant thing of marijuana in it, cannabis or something, right? And they're like, hey, I would use this for my stockpile of cannabis. Who knows? Like, who knows what in the world people would use this for?
Yeah, I mean, as long as they're not harming other people, I think.
Yeah, you just never know. There could be all kinds of different uses for the technology, right? So, what I'm really curious. So, you built the technology, and no doubt it was really difficult to perfect how to build this. All the engineering, like you said, robotics, mechanical engineer, software developers, all these different components. We could probably talk all day about how difficult that really was to pull together. There's so many headaches in building hardware. But I'm curious, what was it like for selling this? Like, once you've got a prototype, you built the product, how has it been, with your go-to-market strategy? Like, okay, how do we sell this thing, and who do we sell it to?
I mean, on one side, we've been very fortunate because we've gotten a lot of interest from very early on, and we as soon as we put out the website out, or people would hear through kind of word of mouth about what we were working on, we just regularly been getting like inbound inquiries, and so we've hardly been doing like active outreach, other than in situations where say we were going to a new area, we were maybe spending like a few days there, and so we wanted to kind of maximize the use of that time and meet as many people as possible in that place. But otherwise, we've just been kind of fueled by inbound inquiries, really. And the usual feedback that we get is how soon can we have one of these, right? So it's been a positive situation, but at the same time we've had to manage expectations, because as a young early stage company with like limited capabilities, we couldn't really work with absolutely everyone, especially since like some of the inquiries were also from other parts of the world, and we said initially, we are based in Edinburgh in Scotland, so we've been working with a few selected partners in the UK and in Italy. We've been lucky enough to be able to kind of pick the ones that were more suitable for, that kind of early stage iterative process of, continuously improving the product. And yeah, we've been working with some amazing partners that enabled us to, get to the point that we're at today. But I think the key thing is obviously, just working with the end users as much as you can, and getting their feedback and making sure that, you're not building what you think should be built, but more what they want.
So would this, in theory, work for rice?
It can work for rice. We've done some work with rice in the north of Italy. Unfortunately, there's no rice grown in the UK.
I was going to say you need to go to Southeast Asia with this thing as fast as possible for rice.
Yeah, totally. I mean, for now we don't want to kind of stretch ourselves too thin, but you're right. Yeah.
So I guess what I'm thinking about in my head is like, who do you sell this to? Are you selling this to some kind of commodities exchange, or like, do you go and partner with like local like agriculture or like co-ops, or are you going to each individual farm? Like, I'm thinking in my head, like, who do you sell this to? Like, at what layer of the system?
Yeah, I mean, it could be used by any of those, but primarily we focus on centralized storage operators.
Okay.
So the likes of grain merchants, cooperatives, and port operators primarily. And I think that's also due to the way the market, like the grain storage market, is fragmented in the UK and Europe, where like farms here tend to be relatively small compared to like, US farms. But then, when you look at Kansas and other places in the Midwest, that's obviously a different story. So I think, for our US activities, we're probably going to be working even more with farmers. And I mean, we've been working with farmers here in the UK, but they're not really our main marketing target, really, just because here they store small quantities. They're more kind of price sensitive, and also they tend to try to get grain out of the store as soon as they can, because they don't have the
they want to send it on to the next stop as fast as possible. So how long did it take you to build this from kind of idea phase to having like a working sort of prototype?
Yeah, it's one of those things that takes much longer than you realize, I think. So
just a weekend, right? It just takes like a weekend.
Yeah, and I mean, initially, I also thought, I'm going to build it all on my own, and obviously that wasn't possible. So we had to build a team, and building a team requires funding, and when you're a first-time solo founder, it takes time to just convince people that they should give you substantial amounts of money to make that possible as well. And so, if I'm not mistaken, like the original kind of physical concept I observed in 2016. I was still doing the PhD then, so it took a bit of time to get all of that processed. Started the business around 2018, but it was still just me, and it was mostly to kind of work through kind of some of the patent filings and start applying for grants and things like that. And so like things really kind of kicked off around like 2020, 2021. That's when we really kind of started getting some full-time people on the team. And so it's quite a substantial amount of time. Initially I thought this is going to take a few years and then I'm going to be a millionaire, but it just it takes longer than that, right? And I think we still have a way to go before we reach all our targets, but it's getting really exciting now because a lot of the things that we planned for years are now finally happening.
So then when did you get your first paying customer?
That was probably 2022.
Okay.
And we also didn't want to kind of just make too much commitments early on, just because we knew that the technology wasn't super mature and super ready. And so we just worked kind of on a project basis with primarily kind of 6 partners um, that provided us a variety of types of storage, geography, type of crops, and so on, so that it gave us like a benchmark to be able to build something and iteratively get feedback, kind of practical feedback that would then be applied to the largest kind of market segment as possible.
Well, I think this has been a really, really cool story. And I could definitely see, you talked about filing a patent. Um, can you tell us a little bit about that process? Because I know there's a lot of people always think they want to go file a patent, especially for just basic software products too. But this sounds like something that genuinely should have a patent, maybe multiple patents, because it's very unique. It's a physical device, and all the problems it solves is very unique. So tell us about that. And I'm specifically interested in how you deal with having a worldwide patent.
Yeah, this could be a very long conversation. I think, okay,
It was
patents
the short
are
version.
very, yeah, no, they're a very interesting topic. And I really enjoy, like talking with our patent attorneys. I think I learn new things all the time. I've grown like very skeptical of patents over time just because they're very expensive. And I think the return of investment in the end on them is very limited. Like their primary purpose in the end is mostly to just scare people off. And even if you have like really broad scope of protection, like in our case, so we've got now 3 patent families, and the first one of those we've already got patents granted in in the UK, in the US, in China, in India, and we've got a few more patents around. And when you're talking about like an international patent protection, there's no real such thing, right? You file what is called a PCT, but then you've got to select after 30 months which specific territories you're going to want to seek protection on. And the more you pick, the more expensive
Yeah.
it is. So you got to make sure that those are actually markets that you want to sell or manufacture into. And and the process just kind of keeps on getting more expensive over time, right? So I think just the old way the system works, it doesn't really favor the inventor. If anything, you know in the end you end up incurring more costs than than you get out of it. But obviously if you've got a big idea and a big business to build, it's almost like a necessary thing that you got to do, right? But yeah,
It favors the lawyers who get paid to do all this.
100%. Yeah. I think there's like some inverse relation between like GDP growth of a lot of countries and the number of lawyers in that country, and I think this is a really good example of that.
Well, I've really appreciated having you on the show today. And I do want to remind everybody, if you have a startup, maybe as cool as Lorenzo's that needs software developers, or if it's just your traditional web application, mobile app, normal kind of tech you think of, you can check us out at fullscale.io. We have over 300 developers working for companies all over the world, actually, building all sorts of cool stuff. So check us out at fullscale.io. Well, Lorenzo, everybody, this was Lorenzo Conti. He's the founder and CEO of Crover. That's crover.tech. We'll have a link in the show notes. Very, very cool technology. Very, very cool story. I especially wanted you to have you on the show because it's just such a fascinating, different kind of technology and different kind of business than a lot of the people we have on the show. And that definitely was the case. It was very, very cool stuff. And it's amazing all the things that people are building out there, right? Like a lot of us are building like little tech products that are like line of business, add something to database, reporting, whatever kind of technology. And you're building robots to basically swim through grain. So this is really cool. I'm curious if you have any final thoughts or words of wisdom as we end the show here today for other entrepreneurs.
I think just make sure that you're committed to what you want to build for the long term, because it's like we were saying, it's going to take some time. But if it's something that you really care about, and you're ready to make it really your primary goal in life for at least the next 5 to 10 years, then definitely go for it.
Yeah, it sounds like it took you 5, 6, years from original idea and PhD research and all that to having a working product. So you're an overnight success, Lorenzo. Congratulations.
Thank you, Mario. It was a pleasure to be here.
All right. Thank you so much for being on the show today.